We are studying circuit analysis, and in last couple of lectures we have been studying three-phase Y-connected source and load. But in this lecture we will study three-phase delta-connected source and load. Right. The primary difference between the delta and the Y system is the way in which the source and load components are connected. Right. Both the source and the load are connected in the form of Greek letter delta in this case. Right. We have these sources A, B, and C, and three terminals, small a, small b, and small c, corresponding to the source side. This means we have three voltages, VAB, VBC, and VCA. Right. But unlike Y-connected system, we don't have any phase voltages. Right. So we have only one set of voltages in case of delta connected system. They are VL. They are actually line voltages. We use the term line voltage and phase voltage in our last lecture. And we also studied that line voltage is 1.732 times larger than the phase voltage. So in the case of delta connected systems, we have only one voltage. In fact, we have only one set of voltages, VAB, VBC, and VCA, and they are line voltages, and to fulfill the requirement of the balanced three-phase system, they have to be 120 degrees apart from each other. Similarly, on the load side, we have terminals capital A, capital B, and capital C, and we have three voltages. The magnitudes of these voltages can be different, but there is only one set of voltages, both on the source and the load side. But unlike Y-connected system, where we have only one set of currents, here we have two sets of currents. In Y-connected systems, we have only one set of currents and two sets of voltages. Here we have one set of voltages and two sets of current. So they are actually opposite to each other. Line current and phase currents. Line currents and phase currents. Line currents are IL if they are at angle of phi, then IB, the second phase current, line current has to be 120 degrees apart. IC should be further 120 degrees apart, right? But the phase currents, and we studied in Y-connected systems that phase voltages are 30 degrees lagging compared to line voltages. The same applies here. Here we have two sets of currents, so all phase currents are 30 degrees lagging compared to their line current counterpart. So IA, the counterpart of IA is IAB, so it is 30 degrees apart, 30 degrees lagging. So this is also 30 degrees lagging compared to IB, and this final current ICA, the phase current, is 30 degrees lagging compared to IC. And we have already studied that all line quantities are under root 3 times IP, or the phase quantities, or the phase quantity is the line quantity divided by square root of 3. Right. So in order to summarize what we have studied for Y and delta connected systems, let's make a summary in tabular form. Here I have made a summary in tabular form to better understand the Y and delta connected systems. Right. A line voltage, the term line voltage and phase voltage, these two terms are used in case of Y connected system. The phase voltage is, if it is VP at an angle of theta, its counterpart line voltage is under root 3 times VP. The magnitude is larger, 1.732 times larger, and it is leading by 30 degrees, or phase voltage is lagging its line voltage by 30 degrees. But in case of delta, we have only one voltage. which is equivalent to the line voltage in case of Y connected system, right? For delta connected system, we have two currents, line currents and phase currents, but for Y connected system we have only one current, right? What is the difference between line and phase current in case of delta connected systems? In delta connected systems, if Ip is the phase current at an angle of phi, the line current would be under root 3 times Vp Ip at an angle of phi plus 30. Whereas the line current in case of Y system is under root 3 times Ip, it's equivalent to the line current in case of delta systems, right? So now let's see what is the difference between the phase current and line current for a delta connected system, right? If we look at this triangular representation in a bit more detail, this is a delta connected source or load. So in order to better understand what is the difference between IL and IP, the line current and phase current, I have redrawn it, and I haven't mentioned that whether it is a source or load. But in any case, the current that is outside this delta is the line current, and the current that is found in any in any of the inner branches of this delta, like of this triangular type shape, is the phase current. Is the phase current, right? So that's all for this lecture. In our upcoming lecture, we'll continue studying delta connected systems, and we'll hopefully solve some problems so that we can understand delta connected systems better. Thank you.